class, so I'm going to explain today for science about the effect of heat energy and how it can transform, and also how that has an effect on density in an object, on how much and how little density an object has based on how hot or cold its state is, okay? And I'm going to be explaining this in depth through a specific experiment about how golf balls bounce. Okay, so first we're going to start off, as we start off every experiment, with a hypothesis. Okay, so we're looking at our variables, looking at what we're testing and what we're hoping to get out of this test, right? So our hypothesis is, what is the effect of a golf ball left in the freezer for 3 hours have on how high it can bounce? Okay, and look, this is a picture of me. This is me leaving our 10 golf balls in the freezer, right? Because we're going to be looking at, our question is, what is the effect that freezing golf balls has on its ability to bounce? So then we come out with our outcome statement, okay? And this is what we think is going to be the result of our experiment, okay? Kind of like an answer to our hypothesis that we just asked, okay? So the golf balls at room temperature will become less dense and they will be able to bounce higher, okay? Then we have our content statements, okay? So then we're getting into the science behind our experiment. So what is the science concept examined in this experiment, okay? And this experiment is going to be examining the thermal energy, okay, the heat energy between the room temperature golf ball and the frozen golf ball. And we're looking at the density difference, okay? Is there a difference in the density between the frozen golf ball and the room temperature golf ball? And our next question would be, what is the key vocabulary for this experiment, okay? And we look at density, which is an object's mass per unit of volume, okay? The density is how packed are the particles in an object, all right? How dense, how packed are those particles in the object? And then our next word is going to be heat energy, which is thermal transfer, okay? The temperature transfer in an object, and what happens due to that, right? What happens due to the heat energy transfer? Our next question we're going to answer is, how does the science concept apply, okay? So we will be testing specifically in the golf ball, right? The transfer of heat. We have the frozen golf ball, and we're going to look at, with that heat energy in the frozen golf ball, what is the difference in the density, okay? How are the particles being more compact in the density? Because we know if something is colder, like ice, right, in its solid state, our particles are going to be very compact. They're not going to move that much, okay? They're going to be tighter, versus a liquid or something at a more room temperature, something at a hotter temperature. The heat temperature difference, okay, the thermal energy in something warmer like a room temperature golf ball, we're going to think that that density might be a little bit less compact, okay? Because our particles have more room to move, okay? Our solid is kind of, they're moving, but they're not moving that much, all right? Because they're compact and they're more cold, opposed to our heated object or room temperature object, right? And those particles are going to be a little less compact. So we're trying to see, based on the heat energy difference and the density difference, okay, and result to that heat energy, how is the bounce going to be different on these golf balls? Will they bounce at different heights, right? That's what we're looking at. So our variables are first going to be, our manipulated variable is the temperature of our golf balls, right? That is what we're changing. Our manipulated variable is, we're having 10 golf balls at room temperature, which is going to be 73 degrees Fahrenheit, and then 10 golf balls at a frozen temperature for 3 hours, which is frozen at 0 degrees Fahrenheit, okay? Two big different variables that we'll be testing both. that is the variable that we're manipulating. That's the variable that we're changing. Our responding variable, okay? Due to the change that we are making, what are we seeing out of that change? We're looking at the responding variable being how high the balls bounce, okay? How high is the frozen golf ball going to bounce in opposed to how high the room temperature golf ball is going to bounce, okay? We're looking at if that variable is going to be different. And what is staying the same? What is our constant, okay? So we're going to be using the same type of golf ball in this. We're going to be using a top flight golf ball, all right? Both frozen and room temperature golf balls are going to be the brand Top Flight. So that is a constant. Another constant is that we're going to be measuring these golf balls being dropped at 60 inches, all right? Right here. So we're going to drop them from this height, and each one is going to be measured from 60 inches high, okay? And we're going to drop them all just on a tile floor just like this. Okay, so the material of what the golf ball is being bounced on is also going to be a constant, as well as we are measuring the height of the bounce in inches as well for each one of our variables, okay? So then let's look at all of our materials, okay? Our materials are going to be our tape measurer. And then also specifically for this, I'm not going to be able to be holding the tape measurer, right? So we're going to be laying it down like this. Let's get that 60 inches. It's going to be laid down like that on our tile floor. And I'm going to secure the top with some tape. You can see I did there in the picture. Secure the top with the tape, okay? And then we also have our room temperature golf balls and our frozen golf balls, all right? We have our tile floor. And then we have the tape that we secured our measurer with. And then to be able to really see our results, right? Because I will be busy bouncing these balls. That's what I will be doing. Okay, that is how we are going to conduct this experiment. So am I really going to be able to see how high that bounced if I'm focused on trying to bounce the ball correctly? No. So what I'm also going to need is a camera, a video object, anything to video, and then also a tripod to hold up your camera if you do not have someone to help you. Okay, I have a picture right here of the tripod I use. It was a chair with a bunch of boxes on top of it. Like whatever you need so that you can make the best, most accurate data, okay, to be grafted on explicitly how the manipulated variables change the outcome. All right, so our procedure now, how do we start this? How do we go through this experiment? We start off with freezing 10 Top Flight golf balls for 3 hours, okay? We have 10 in the freezer and we have 10 out. That's how we start off. Then we set up our tape measure against our wall up to 60 inches long. Secure that on top with tape, okay? And then you want to set up your tripod because you're going to make sure that your tripod, you want to set it up ahead of time to make sure that it's eye level, okay? Because you can have it at different angles and you're not going to be able to see exactly how high, exactly how high that bounce was because we're measuring it at the very peak of the bounce, right? Right there. As high as it goes on the first bounce, okay? And then you're going to start recording. And once you start recording, you go ahead and you drop it from that 60 inches. You drop your room temperature golf ball 10 times, and then you drop your frozen golf ball straight out of the freezer 10 times, okay? And then once you're done, you can stop your recording and then you look over that footage, okay? You might want to pause. You might want to slowly go through the footage so you can see exactly the exact inches in which your bounce reached, okay? Because it's not going to be the easiest thing to see with a naked eye. You might need to zoom in a little bit, okay? And then after that, you're going to record all your data, record each bounce. You're going to do 20 trials, 10 frozen, 10 non-frozen. And then after you record your data, you're going to analyze it and analyze your hypothesis and see, did your hypothesis, were you correct? Right? What did your hypothesis tell you? And then you're going to write your conclusion, okay? based on the question that you asked yourself, the conclusion is this was the answer to my question. These were the results that I had, okay? So this is the data that I was able to conduct after my 20 trials, all right? And I see I put each one. This is my golf ball at room temperature. This is my golf ball at frozen. And I did each trial. I put the specific number on the peak of how high it bounced in those inches. And then I conducted my total and found my mean, my average. On average of all 10 bounces, what was the average of all the bounces, okay? And I found for my room temperature golf ball that was 48.05 inches. That's how high the average room temperature golf ball bounced. And then for my frozen golf ball, the average was 44.55 inches. Okay, so there was a difference. There was a difference, but not that much of a difference. And then after we find our mean, we want to go find our median, mode, and range, all right? And for my frozen, the median and the mode were both 45, okay? And our range was 1.5. So there wasn't that much of a difference with our frozen golf ball, right? They were within a very tight range of only 1.5. And opposed to our room temperature golf ball, the median and the mode were also the same number at 48, and then our range was 2.5, okay? So a little bit more of a range, but really not that much, okay? There was not that much varying in between the data that we collected. So after you have all that data, you're going to want to graph it. You're going to want to graph it clearly in a bar graph so that you can see, without having to look at all of your numbers, right? What was the mean between these two? And we have, this is our frozen, and this is our room temperature. Okay, you can see there's not that much of a difference, right? There's not that much of a difference at all. But there is a difference in the room temperature being slightly higher. The room temperature ball was able to bounce slightly higher than the frozen one. So then we look at our results, okay? And we're gonna wanna write out our numerical findings, right? We're gonna want to write out our data in a way that it's easy to read. So I just write out the average height of the room temperature was 48.05. The average height of the frozen balls was 44.55 inches, right? And we want to make sure we keep our units the same. These were all in inches. We measured them all in inches. And then we talk about our range. The range for the room temperature ones, which went the highest, was 2.5 inches, while the frozen was 1.5 inches, okay? That was our range. So then we write our conclusion, okay? We're going to clearly state our answer to what we found to our hypothesis, right? Our hypothesis was, is there going to be an effect on freezing these golf balls on how high they bounce? And in conclusion, we found that there was a difference, okay? And we want to bring in our science aspect to this conclusion. So we have our room temperature golf balls. In conclusion, we found out that due to the heat energy, all right, these golf balls were less dense. Due to them being at 73 degrees Fahrenheit, they were less dense, okay? And because of that, after our trials and our experiment, these balls bounced higher, all right? They were able to react higher to the impact of the ground and move more because they are less dense, all right? Opposed to our frozen golf balls at 0 degrees Fahrenheit, all right? Because of their thermal energy being colder, they are more dense, all right? Their particles, they're more dense, okay? So then, based on their thermal energy and their density, right? They're heavier, more dense than the room temperature golf balls. We found out that they don't get as much movement after being bounced, right? They proved after 10 trials that they were lower in height than the room temperature, okay? So that is answering our conclusion that is answering our hypothesis and our conclusion that yes, there was an effect in the thermal energy because of the density to the height that these balls were allowed to bounce, right? The room temperature ones at 73 degrees Fahrenheit were able to bounce higher because they are less dense than our frozen golf balls, which are more dense. So now we think, how can we apply this to our real world, right? What was the point of this experiment, okay? Why are we freezing golf balls and why are we bouncing them and seeing what the difference is? Well, we were able to learn the science out of it, right? That objects that are more dense in colder conditions are not going to be able to travel and react to movement as much as a less dense golf ball or object. But in the real world, right, if we're not scientists, how are we going to use this information? I say that this would be pretty important to golfers, right? Golfers, when they're out on the range or the driving range or wherever, and they want to know how their swing is doing, or they want to participate in a competition, right? They need to take into effect that if it's a colder day, or if their equipment has been stored in colder conditions, their ball is not going to be hit as far, right? It's going to react less than, say, a room temperature or a ball that is in conditions on a really hot summer day, right? So if you're going out in January to hit golf balls, your balls might not travel as far after being hit by your club or bouncing off the ground, opposed to on a day in July going to the golfing range, right? And you're hitting your balls. Because of the density in these balls, you know that your ball is going to go a lot farther in the summer because of the weather, right? And I think this would also be beneficial to golf production facilities, right? The people who are producing the golf balls, the people who are producing the clubs. So a production agency or company or facility is going to maybe think, there's effect on the weather and our golfers' ability to perform. Maybe we should produce a golf ball that performs better in the cold. Maybe we should produce a golf ball that somehow the fibers that it's made out of does not get affected by the coldness or the weather or the heat energy, right? It keeps its density no matter where it is. Or maybe it's not as much affected, right? Because we know in colder areas, the density is going to get affected. But maybe they come up with something that doesn't affect as much. These are all important things, right? These are why science is so important, because we can use it in the real world in more than just a science lab or more than just a classroom, right? We can apply it to real life situations in which it can help us and others. So then I just have my narrative diary on each day that I was able to conduct this experiment, all right? First, I reached out, okay, and I made sure that this was an okay topic and it was okay for me to go on with this, all right? And then I got the okay, and I proceeded. I borrowed the golf balls, right? I accumulated all of my materials. I figured out where I was going to be able to set up my experiment. And then I proceeded on with my experiment, tallied up and recorded all of my data, went over all of my data, and then analyzed my hypothesis on how it was affected by the data and how I was able to write my conclusion because of it. And that was how a proper experiment gets to go, all right? And that's how we are going to be able to go on with our experiments throughout the rest of the year.